Welcome back to C++ discussions. Today we are going to discuss about another type of argument passing mechanism, that is called by reference with help of reference variable. So we can start with reference variable. Reference variable is nothing but it's an alias of already available variable. Here we can see with help of an example. You know Amitabh Bachchan, right? Some people are calling Amitabh Bachchan as Big B also. Now, Big B is nothing but it's an alias of Amitabh Bachchan. Now you can refer this Amitabh Bachchan with help of Big B. Now I am telling Big B's birthday party. Big B's birthday party is nothing but it's the birthday party of Amitabh Bachchan. Big B is going to release a new movie. Who is going to release the new movie? Amitabh Bachchan is going to release a new movie. So whatever the changes we are making with the help of Big B, that is going to reflect over Amitabh Bachchan. This concept is known as a reference variable. We can write a small program for reference variable and we can see how which is internally working. And the syntax of this reference variable is first data type, then you have to put a symbol of reference, then variable name, then where you supposed to refer, another variable. This is the syntax of reference variable. This symbol is reference symbol. Now you might be met with this variable, right? If ever you are using this variable, left hand side of the assignment operator, you can call it as a reference variable. If ever you are using this variable, right hand side of the assignment operator, you can call it as an address operator. So here I am using this simple left hand side of the assignment operator, that's why it is known as a reference variable. Now we can try to write a small program and we can see how this is internally working. As we discussed, reference variable is nothing but it's an alias to an already available variable. So I am writing int I which is equal to 10. Now I am going to write a reference variable which is of the type integer, which is going to refer the value I. Here I am writing int reference x which is equal to I. Okay. Now we can try to draw the memory picture and we can see how this is internally working. Here I am drawing I which is equal to 10. Assume this is available in a memory location 7000. Now I am going to write the memory of this reference variable. Here it will be reference x. This reference variable which is referring the variable I. So here it will be this is referring the variable I. So this reference variable which is holding 7000, that is address of the variable where he is referring. Now the address of the reference variable is 6996. This is the reference variable. Now I am making some changes to this x with the help of reference variable. We can see what is happening. Here I am writing x is equal to 20. Compiler internally considering this line as dereference the address which is held by the reference variable and change that value. Now this reference variable is holding 7000. Dereference that, so whenever he is dereferencing the 7000, he will get I. Now change the value of I into 20. So this original value which is getting changed. That means now this x is a alias of this I. Whatever the changes you are making with the help of x, which will be reflecting over I also. also. Now this reference variable, which is internally compiler consider as a constant pointer. So for the compiler, this is int star const x. Compiler is considering like this. That means it's a constant pointer. So which will show all the properties of a constant pointer. Properties of the constant pointer is, if ever you are pointing to some, or if ever this constant pointer is got initialized with some address, you cannot point to some another address. You will get an error. For example, assume I have one more variable, int p, which is equal to 100. Assume I am trying like this, reference x, which is equal to p, you will get an error. Why? Because this reference variable is internally, it's a constant pointer, so you cannot change, or this constant pointer cannot point to some another address. That is not possible. This line you will get an error. Now one more thing, if ever you are trying to take the address of the reference variable will not tell its own address. Reference variable will give you the address where the reference variable is pointing. For example, we are taking the address of Big B. You will get the address of Amitabh Bachchan only. You will not get the address of Big B itself because it's an aliased name. So if ever we are trying something like this, see out of address of x, you will not get the address of the reference variable. Instead of that, you will get the address where the reference variable is pointing. Reference variable is pointing to I, so you will get the address of I only here. That are the differences. Now reference variable is nothing but internally it's a constant pointer. User is no need to take the address, and user don't want to pass into the reference variable. Compiler will internally take the address of the reference variable and he will pass into the reference variable. Here you don't want to pass any address. Compiler will internally take the address of this variable and it will pass into this variable. Again, user is no need to dereference the reference variable. Compiler will internally dereference the reference variable. We can try to write the equivalent program with help of pointer variable, and we can compare what is the advantage of the reference variable. Here I am trying to write the equivalent code with pointer variable, and we can see here I am writing int I, which is equal to 10. Instead of this, I am using a pointer variable. Here this is a constant pointer, so here I am writing const x equal to address of I. Here, if ever you want to change something, you have to dereference here. X is equal to 20. Now you closely observe. Here what happens? User need to take the address and user has to pass into the pointer variable. Here compiler will take the address and compiler will pass. You don't want to pass the address. Now here what happens? User has to dereference the address. Here user don't want to dereference the address. Compiler will dereference the address. This is known as reference variable. Syntactically simple compared to the pointer variable, but which is internally a constant pointer. Since it's a constant pointer, once you are pointing one variable, you cannot point to any other variable. Just like your arranged marriage. Once you have married someone, you cannot marry other fellow. Here, the reference variable is just like a arranged marriage. Hope you understand it. Now we can write our SAP program with help of reference variable, and we can see how it is working. Now I am going to write our old subprogram. Here I have int main. Inside main I have two variables, int I and j. I which is equal to 10 and j which is equal to 20. I am calling mySub function my swap. Now I'm swapping with the help of a reference variable. So you don't want to pass the address. Compiler will pass the address for you. Here I'm just writing I comma j. Next I'm trying to print out I j, and I'm adding some next new line character also. This is my program. Now we can try to implement my swap function. Here, void, my function name is my swap. Now I am using reference variable as the argument of this function. Int reference x. Again I am writing int reference y. Now I wanted to implement the logic of the swapping. Here I am using int temp. Next line I am writing temp which is equal to x. Next line I am writing x is equal to y, then y which is equal to temp. Now we can try to draw the memory picture and we can see how this is internally working. INJ which is local to the main, so INJ which is getting memory inside the stack memory segment. Here I have two variables. One variable is I and another one is j. I which is equal to 10. Next one j which is equal to 20. Assume this address is 7000 and assume this address is 6996. This is the stack memory of main. Now we can try to draw the stack frame of my swap function and we can see. Here I have a reference variable x and I have a reference variable y and I have a local variable temp. This is the memory picture. For example, these addresses are some different address. This is 6000, this is 5996, this is 5992. These are the addresses. This is the stack frame of my swap. Now this address of this I which got passed into x. So address of this I which is got passed into the x. So this x will be 7000. Now the address of the j which is got collected over y. Address of the j is 6996. 6996. Now we have a local variable here. Now this x and y are alias to I and j. Instead of I, you can use x. Instead of j, you can use y. Now here I am writing temp which is equal to x. So compiler will dereference the address x. X is pointing to 7000. So it will dereference the value, that is temp which is equal to x. He will take the x he will get x is equal to 10. He is copying this 10 into the temp. So here it will be 10 now. Now here I am writing x which is equal to y. Compiler will dereference the y, then he will copy that into dereference of x. So he will dereference the y. Y is what? Y is 20. 20 which is getting copied into where the x is pointing. Where x is pointing? X is pointing to 7000. So this 20 which is getting copied over here. Now y which is equal to temp. So y is referring to j. Y is equal to temp. This temp is getting copied into y. Temp is getting copied into y. Now you see our source is got changed. Now we are trying to print the output. You will get 20 and 10. So if ever you are making any changes with this variable, which will reflect over the original value, this is what is known as reference variable or argument passing mechanism with help of reference variable. Hope you have understood this one. Thank you for watching this video.